Hey guys, this is the Chemistry Unit 4. We are in Chapter 10, Section 3, Part 1 notes. So today we're going to be talking a little bit about percent composition, just kind of like an intro, get your feet wet of percent composition, and we're going to talk about how that relates to compounds no matter what sample size you have of that compound. All right, so first thing you need to know is compounds. So we're talking both ionic and covalent. Remember, ionic starts with a metal and a complete transference of electrons versus covalent, they are sharing those valence electrons. If it's a compound, as in not a mixture, then it always has a set ratio of elements. What I mean by that is every water molecule is made up of the formula H2O. So here's my sample of water that we're going to be looking at the rest of these notes. And if you notice, every single one of these has 2 hydrogen and 1 oxygen. So forever and ever, ever, anytime you have 2 hydrogen, 1 oxygen, it's always water. It doesn't matter what state it is, like solid, liquid, gas. It doesn't matter what size the sample is. If it's water, it's H2O. Always. Always. Okay, so that means that the rate by mass of each element is always the same because every hydrogen atom is always the same size and every oxygen atom is always the same size. So you're always going to have the same percent by mass of each of hydrogen in every water sample and oxygen in every water sample. So here's a sample problem. When you run an electric current, which I don't recommend doing, by the way, through 64.8 grams of water, it breaks down and it makes 7.2 grams of hydrogen and the rest oxygen. So what mass of oxygen is released? To answer this question, you need to know a very important principle, and that's the law of conservation of mass. Mass cannot be created or destroyed, which is a really fancy way of saying whatever your starting mass is, that's your final mass too. So if you start with 1,000 grams, you're going to end with 1,000 grams. If you start with 2 grams, you end with 2 grams. So whatever mass you start with is the mass at the end of your reaction. So if we go back to this question, if we start with 64.8 grams of water, that breaks down to form 7.2 grams of hydrogen and some grams of oxygen. Well, we know we started with 64.8 grams, which means we ended with 64.8 grams. So now it's just some simple algebra. 7.2 grams plus what will give us a total of 64.8 grams? And the answer is 57.6 grams. So your answer is 57.6 grams of oxygen. And now it's always going to have this ratio, right? Whatever percent of oxygen is made, that's the percent that will always be made. Let me explain. What is the percent by mass of hydrogen in water? Okay, so we know that if we have 64.8 grams of water, 7.2 grams of that was hydrogen, because that 7.2 grams of hydrogen and the 57.6 grams of oxygen would come together to reform into the 64.8 grams of water. So we're going to use this formula, and this is how you find percent composition of an element by mass. So you always take the mass of the element, you divide it by the mass of the compound, and then whatever you get there, you multiply by 100, and that gives you your percent by mass. So let's do that for hydrogen. So our first thing says mass of the element. So the element is hydrogen, and we had 7.2 grams of it, divided by mass of the compound. Our compound is water, or the whole thing, so you divide by 64.8 grams of water. And then in our formula, we always have to multiply by 100. And in your math class, you learned that's because percentages are actually decimal forms, and when we have the percent sign, you have to bring it up to those whole numbers. So you always multiply by 100 or move the decimal over 2 times to the right. I just multiply by 100. It's easy because you can plug it into your calculator. So that equals 11.1% of hydrogen. You could have written the word hydrogen, that's fine, or if you remember that hydrogen is a diatomic element, you know that since it's released by itself, it's going to be H2. All right, let's do another one. What percent by mass is oxygen in water? Okay, we're doing the exact same thing, but now we're talking about the other element. So we had done hydrogen, now we're going to do oxygen. So mass of the element would be 57.6 now, because we're talking about oxygen. Mass of the total compound is what it broke down from, 64.8 grams of water times 100. Plug it into your calculator and you're going to get 88.9% oxygen. Now, keep in mind, it's not always going to be decomposition, right? You're not always going to start with your substance. Maybe you'll have a problem where you build up your compound, or maybe you just have a regular sample, or whatever it happens to be. So make sure you're really carefully reading the questions so you know what's your compound and which ones are your elements, and so on and so forth. Okay, so water is made up of 11.1% hydrogen and 88.9% oxygen. Do you notice something about that? Because I do. I notice that percent by mass for all elements that make up a compound should add up to 100%. 11.1% plus 88.9% equals 100% because your compound needs to be 100% of itself. So this just happens to have two elements. You might have 3 elements, 4 elements, maybe even 5, but the point is, however many elements make up your compound, all of those percentages by mass need to add up to be 100% of your compound. The other thing you need to keep in mind is the percent by mass for each element and compound will always be the same for all samples of that compound. Remember I said water is always H2O. It's always going to be the same. So any sample you ever have of water will always, 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 always be 11.1% hydrogen and 88.9% oxygen. That will never change for any water sample. If you have anything that's not 11.1% hydrogen, it automatically can't be water. So if you have a 113, So using those principles, let's read this question. You have an 11.3 gram sample of water. What mass in this sample is from oxygen? Well, let's bring back our percentages from before. You do need your percentages for this since we haven't talked about how to find the percentages just from the formula. We'll get there next notes. And then you need this formula. So the percent by mass divided by 100 times the mass of the whole compound equals the mass of that element. One thing I want to make sure you know, do not ever use the percent sign in your calculator. Don't use that button. I know it's there, it's tempting, you're like, woo, percent, don't touch it. Just like promise me right now, pinky swear into the computer, you're not going to use the percent sign or percent button on your calculator. Okay, got that taken care of. Great, so we want to know in this 11.3 gram sample of water, how much of it is oxygen? Well, I know it's 88.9% of it. So I do the percent by mass, which is 88.9, divided by 100. What percent means is per 100. So I'm saying out of every 100 bits, 88.9 of them are oxygen. I times it by my mass of the sample. So that is 11.3 grams, and that equals your mass of your element. So you plug this whole thing into your calculator, and you get 10.0 grams of oxygen. Good luck with percent composition. I will see you in the next set of notes. Make sure you come talk to me if you have any questions when you're working through sample problems.